Everyone, September the 12th. Alright, let's see what we have today. Oh, oopsie doozy. Forgot to do this. Let me set this one up. Alright. Let's see. We have, candy. Man, I have 2 questions I have to go through. Now this is a tough one again. Oh, Lord. N children standing in line. Each child is assigned a rating value given in the integer array. You are giving candies to these children subjected to the following requirements. Each child must have at least 1 candy. Okay? Children with a higher rating get more candies than their neighbors. More candies than their neighbors. And the minimum number of candies you need to have to distribute the candies to the children. So if I have 5 candies, you can allocate to the first, second, and third as 2, 1, 2. Wait, hold a second. So each child must have 1 candy, and children with a higher rating get more candies than their neighbors. So this child has higher rating than this, so this needs to be more than this. This needs to be more than this. So these two can have the same, but this needs to have more than this. So I say 1. This can be 2. Such I guess 1 can be because they satisfy the above 2 conditions with a higher rating. So if it's the same rating, it doesn't really have to. So we're given a list of ratings, right? Well, the ones with the lowest, you can say the one with the lowest will have the smallest number of candies, right? But what if we have bunch of kids with the lowest? Then which one? Oh, it's fine, right? If your score is the same as your neighbor, it does not matter. You can have more, you can have less, you can have the same. It doesn't matter. So okay, we will look for the smallest ones. People with the kids with the smallest ratings, they will have 1 candy for sure. And starting from there, we need to look around, right? We need to look around. Well, the reason the smallest score need to have 1, because if you have other kids, even if they are local smallest, if they are bigger than the surroundings, then they need to have more candy, right? Yeah. So if you have a local small and then you say, okay, that would be 1, then you compare it to its neighbors. Yeah, if compared to its neighbors, the neighbors has lower, then you're done, right? So what if we have, can we sort them? Or at least just, get the smallest. We have the smallest candy, we get it. Let's give me 1, right? And we're gonna look at its neighbors, right? We'll look at its neighbors. And once we look at its neighbors, if the neighbors is higher, then it has to be higher. If the neighbor is the same, hold on. The neighbor. Yeah, I'm thinking about this one. Like 1 comes in and then we say, okay, this is 1 because that's the smallest. And its neighbor is 2, right? And 2 is bigger, so this has to be 2, okay? And then we need to push its neighbor in. Well, that is its neighbor, so we push this neighbor in. And you're saying each time we only pop the smallest one so far. We pop the smallest one. Not really like the smallest one. I'm thinking like, can we just start from the smallest and then start to go out? So when this come out, right, this is currently smallest that's adjacent to that, so those has to be 2, okay? And then we push its neighbor in. Okay, what if your neighbor is smaller? With higher rating has to get more candies than their neighbors. Hold on, I have, let me I have some concerns. What if I have 1, 2, 3? Is it just 1, 2, 3? What if I have 1, 3, 2? Well, it'll be 1, 2, 1, right? That's how I imagine it's gonna go. 6 and 5. 6 and 4, my bad. 6 and 4, right? It doesn't make sense. So yeah, you go with the smallest, right? And then what? The ones surrounding the smallest will have to be 2, right? So what I'm saying is, you have an array, right? You have a v1, v2, v3, to vn, and you say this is the minimum, so this has to set to 1, right? Then we can look at its neighbors on both sides. If it's equal, then that will be 1 as well. If it's larger, then it has to be 2. If it's larger, then it has to be 2, right? Then we start from this value. We start to look at here. If this is bigger than that, then it has to be 3, right? That's, yeah. But the problem, if this is smaller, right? This is smaller. If this is smaller than this, then it has to be a smaller value, right? It has to be a smaller value. Now, how small it's going to be, we don't know. We don't know. Because we don't know what's, laying there. Yeah, because you have a v4, you have a v5, right? You don't you know you can say, okay, I know v4 is smaller than v3, okay? Yeah, and if this, actually no, v4 is, we have a v5, have a v6, and then we say v4 is bigger, right? v5 is smaller than v4. If v5 is smaller than v4, right, then this value has to be smaller. So, well, in this case, it's going to be 1. But what if we have something that is, actually, if this is 1, right, what if a v6 is smaller than v5? Like, v3 is smallest, let's say v3 is 0. Right, now we have this, let's go 10. And let's go 8, 6. If you go 1, you said this is going to be 2, this is going to be 1, and boom, it can go, right? Which means this has to be 1, 2, 3. So that shall be 7. I'm going to try. 0, 10, 8, 6. 7? Yeah, it has to be 7. Well, I mean, the whole thing is this just like this, right? You go up, and then go down, and then go down. So when you have this, everything has to be one different. Otherwise, it will be bad. So everything will be one different. So eventually, when you're given it's just gonna be like this, you know? Right, something like this. This is basically how every rating is gonna be. So what? And all we care about is neighboring, right? And that's all we care about. We don't care about. So it's just the neighbors, right? So if we say we go this and this, this, how would you approach it? Let's say we start with a value. I don't know. We start with a value. This has to be a plus 1. And we say this is a. This is a plus 1. This is a. We say we want to less. So I say it's a minus 1. And this is a minus 2. That's a minus 1. This is a. So based on this, the lowest is this. So a minus 2 has to be 1. So a has to be equal to 3. So this is going to be, you know what? I want to try this. I can say 1, 2, 1, 2, 1, 1, 0, 1, 2. We can do even crazier. 10, 100, 9, 10, 100, 9, 99, 8, 8, 0, 1000, 1001. I would expect these two shall have the same result, which is 3 plus 4 plus 3 plus 4 plus 3 plus 2 plus 1 plus 2 plus 3. What's that? That's 7, 10, 14, 17, 19, 20, 25. Does this give me 25? $15 and $15. Lord. But we do see that these two are the same, right? So we have some other issues. Really? How do you figure? Right, this has to be 1. Right? I say this has to be 1. This has to be 2, this has to be 3. And this, because it's higher, so this has to be 2. This can be 1. This can be 2. 1, 2, 1. So 1, 2, 3, 4. That's 10, 15. We probably need to label it slightly differently. I think I might be on the right track. Hold on. So this is bigger, right? So when we set, so this one, I say this is, I say this is smaller than this one. That's not necessarily true, right? Because this is the lowest point. So these are deterministic. These are not, right? These are not. You can go bigger or you can go slower. So this, I can make this bigger. So this point, I can be a plus 1. Or I can be a minus 1, I can be a plus 1. Right? Doesn't really matter. If it's a plus 1, then this becomes a. This is a plus 1 is a plus 2. Right? And a becomes 1. Huh. I mean, the whole goal is to make a as small as possible. Right? The whole goal when we do this exercise is to make a as small as possible. So if we want to make a as small as possible, and when you go down, it's be minus, so we want these to be as big as possible. Does that make sense? Right? When we have this go line, if we have like a couple, so we want, if this a, we want this a plus 1, we want this a plus 2, we want this a plus 3. Because if we artificially raise these value up, now when we go down, this become, it goes down, right? If we go down, then become a plus 2. But hold on, why you go down just to minus 1, right? Well, it's because eventually we want to pick the lowest among everybody. In fact, right, we can start from, it doesn't really matter, we can start from 0, right? Eventually what we want is this value to be as big as we can, because if this is big, right, then a can be small. Oh, but in this case, let's just say if it's this, right, go down, and the smallest would actually be a. So we say that would be 1, 2, 3, 4. That doesn't make any sense, right? You need to make this the smallest. You need to make a plus 2 equal to 1, but you can't because it's plus 2. I feel like we are in the right spot, but okay, let's say we don't have this. We just, go here and then boom, boom, boom. Yeah, then it will be 1. It will be deterministic, right? If everything is like going this, it will be deterministic because they set this as something. As I go up, it has to just be plus 1, and then we go down. Oh, hold on. Go up can be plus 1. Go down, you could be, let's say, right? You can say I can minus 2, right? This can be smaller, and this can be smaller, but we'll pick the lowest to be equal to 1, right? We want the lowest to be equal to 1. Go up is, hold on. So what if we have, we have crazy, we find the minimum point, and this is 1. That's what we say. So when we go up, go down, we don't know, right? At this point we don't know because we don't know what's going to happen later on. But we know around this, that's the best. hold a second. So in this case, actually, each valley can be 1. Right? Each valley can be 1. Each peak can be 2. This is valid. Right? This is valid. Each valley is going to be 1. Each peak is going to be 2. Each valley is going to be 1. So what do we have, you know? I don't know. I'm just playing with this. Can we like say each valley? So we start from here, go up, right? If it's go up, then this is a valley. In the starting position, right? And this is a valley. Go up, go up, go up. And every time we go up, 4. Go down. Okay, we don't know. But then go up. So this is a valley. So go up. Oh, that's the part. Right? We go up, go down, then go down, boom. We can't. So there will be a 0 that we cannot do, which means on this path, so yeah, on this path, so we have a peak, right? So whenever we see a peak, yeah, that's the thing. If we know, because valley is deterministic, valley is going to be 1. Okay, so maybe we can go through and then just mark all the valleys first. You know, we mark all the valleys first. We don't know anything else. We don't care. Okay, we don't care about everything else. We just go through the whole thing. It's a valley. Now we can have actually a dummy value. We can have a dummy value. It's really high. Right, and then we set at this position, and we need to compare to the next one, right? If next is, yeah, and then we go, boom, we find a valley, we find a valley, we find a valley, we find a valley. So now that we find a valley, we can get the valley position out. Yeah, we just have the first position, this position is a valley, this position is a valley, this position is a valley, this position is a valley. So now from this end to this position, so these are the valleys. So in between two valleys, it got to be, you know, some slope, some go up, and then boom, right? That's like, oh, what about this thing? Is this a valley as well? I mean, I guess, yeah, it is. So if we go down, it's equal. So what happened to, like, boom, like this? These are not valleys yet, right? And these are not valleys. And then boom, go up. This is a valley. We can count this as a valley, right? Otherwise these are not. But this counts as a valley, which means the previous one can be equal to it, right? So valley, the condition of valley is previous one. So like if I have this, what is this? Previous one is larger or equal to you. Next one is, oh, what if we have this? This is a valley. This is a valley. This is, oh God. So maybe we don't worry about this at the moment. What do you say? Yeah, it's hard to say because you can say, okay, this is a 1, right? This is a 1. Yeah, it doesn't matter if I have it like this. Right, so 1, 2, 3, with 4. Right? But this, we don't know what this one is. And then from here, so we don't fill it. And from here, we fill 1, 2, 3. So this has to be 3. Now, these two, it doesn't matter. Well, it has to be smaller than 4. Yeah, it doesn't really matter because it's equal, right? It's equal, so this can be 1, this can be 1. Because it doesn't matter. We can go high or we can go low. So are you saying, actually let's try this one. Let's try this one. We can build this one. So it's like 1, 2, 3, 4, 3, 3, 3, 2, 1, like that. So this is 10, 11, 12, 16, 18. Did I calculate it wrong? Yeah, this is 10, 11, 12, oh yeah, that's 18. This is 10, 11, 12. This is 6. 12 plus 6, 18. This looks, it might be promising. So what you're saying? What I'm saying is, if it's, yes, it's actually right. If it's flat, it doesn't really matter. You can put whatever value you want on the flat. So you don't worry about the flat, right? We don't count flat. We want absolute values, right? We want absolute values. So this is a valley. Now let's go one way, and then the second time around, or maybe we can. So we know this is valley, so we'll add, right? Then when we go down, okay. So we don't know. So everyone had to look left. Everyone has to look left and look right. Okay, look left and look right. Everyone has to look left and look right, but we don't have a left at the beginning. We can push, we can add something on the right at the end. That's what we can do, but on the left it will be a little bit difficult, right? Because we cannot add something to the left. That's why I say I'm going to do a pre. Okay, I'm going to do a pre. So we compare to pre, compare to plus 1. Right? Compare to pre, and as a valley, then we set to 1. Now we here. Right? Now I like this one. And then if this is smaller, this is bigger, it has to be this plus 1. If this has to be plus 1, this has to be plus 1. Right? Now we can here. Right? We compare, that's a value, so we do 1. Right here, this is smaller than this is larger, right? So this is a peak. So it's not a valley, it's a peak. Then we don't know, right? We don't know this one. This one we don't know. So if we hit a peak, or if we hit a peak, so this, okay, so this is a valley. This is a valley too. So if this is smaller or equal to, so if it's, no, left is larger or equal to this, and the right is bigger. these two are valleys. These two are valid valleys. This is a peak, right? This or this, and these are all not. This is a valley. This is a valley. This is not a valley, right? And this is not a valley. Well, this is not a valley because we don't know what's going to happen later on. This is a valley because we know it will go up, right? So if it goes up, then this is a valley. But this we don't know because we can go up, then this is a valley. We go down, then this is nothing. Then we cannot do anything about it. So if we start, if we find a valley, that's going to be 1, right? That is going to be 1. And once we find a valley, if we only go right, then this will become 2, which is not right. Right, which is not right. So how can we fill them up? How can we fill them up? Let me think. I don't know how to fill them up. Or maybe you can we do the length of the stretch? Because the dominant one should be the stretch, the length of the stretch, right? Yeah, as you climb, you just go big. And then once you drop, you climb, and you drop. The drop determines. Right? So it's the peak that you don't know. It's the peak that you don't know. So how about, can we do like maybe 2 paths? Right to left, and then we left to right. So if we do left to right, so we'll do this, that will be 2, 1, 0, -1, right? And this will be 1. So we do 2, 3, 4, and this will be 3. Then 1, 2, 1, 2. So that's left to right. Now we go right to left. 1, 2, 1, rewrite, 2, 3. It cannot be 3. So when we hit the peak, when we hit this peak, so this has to be 4, right? So this is a peak. So if we hit a peak, then it has to be the larger of the 2. If it's along the slope, it needs to be smaller. So that's a 4, right? And then we larger of the 2. Then we don't consider this. We only consider the rising edge. So for the rising edge, 1, rising edge, 2, 3, 4, 5. Rising edge, had before. Rising edge, so, what, okay. Does that make sense? Because when you go left to right, when you go this direction, this is kind of deterministic, right? You know what this one is. But this, you don't know because it can drop really, because you basically just set whatever the top value this is going to be. You don't know if this is the correct top value. You have no clue, right? You have no clue if this is the correct top value. All you know is you go all the way up, and this is the smallest you can achieve, right? It's the smallest you can achieve on the rising edge. And when you want to go down, you don't know, because this might drop a little bit, then it's the best scenario. This might drop tremendously, then this will be a wrong value, right? But you don't know, so you just handle the rising edge, right? And then if it's the drop, you just don't worry about it. You don't worry about the drop. Just you let it go. So it's a drop, you just let it go, let it go. And then once you find there's another valley, you set it to 1, then you do again. So this will be 2. Right, so you go 1, I know this is a valley, this is a rising edge, so we hit, right? Then we go, next one is a valley, so we set a 1. Next one is a peak, right? Next one is a peak. So when we hit a valley, then we hit a peak. Then we will, yeah, because it's the rising edge, right? So if this is larger than this, if this is larger than this, then we just set it, doesn't matter, right? Larger than this. And then we have a new one, which this is a dropping, right? You drop, this become a drop. If it's a drop, then we don't set a value. We don't know this value. This is still a drop. This is still a drop. This is still a drop. We don't set value. And this is a rising. Now we have, so hold on, let me do that one more time. Everyone has to check this and this, right? If this is larger than this and this is smaller than this, we're in the rising edge. So we have to set value. If this is up and this is down, then we are a peak. So still we'll set it. And this is a valley, we set it to 1. And this is a peak, right? So left to right is a peak. We just set it. A peak, we just set the larger value, right? And then this is a dropping, right? If it's going down, then we don't do it. This one don't do it. This one don't do it. This one don't do it. And this become a valley, so we set it. This is a rising edge. This is a rising edge. This is a peak. And this is a dropping, so we don't set it. This is a valley, rising. This is a peak, drop, peak, peak. Okay, so we go left to right. Now we go right to left, right? As we go right to left, because at the end I'll append a giant value, right? So for this, yeah, you know what? I think I will just put a giant value at the front and at the end. It just makes things so much easier to deal with. So 3 times we have to go through. Or unless you you either do a check. No, I'll just add another value here, add another value. So here, this one is going down, right? So going down, don't worry. This is going up, right? It's a peak, so we need to find the largest. So still 2, going, and this is a valley. So we set it to 1, right? and then this is going up, right? So if it's going up the trend, so we'll take it to be 2. And if this is a peak, should be the larger of this, so be 4. Going down, this is going down, don't care. This is going down, don't care. This is a valley, we set it to 1. This is going up, this is going up, this is going up. This is a peak, so we do the maximum. And this is a valley. This is going up, we do the maximum, and then that's that. So this one, I would say that's a 10, 11. This is 15. 11 plus 15 is 26. 26 plus 9. 26 plus 9 is 35. Plus 3, 38. 40. 41. 43. 43. Can we get this one? 43. So 1, 2, 3, 4, 1. 5, 4, 3, 2, 1. 2, 3, 4, 2, 1, 2, 1, 2. That's, I just put these value in. 43. Okay, so I think this one we have resolved, right? So the last problem is these things. What do we do? So again, if we go up, yeah, and then we have a peak, it's fine. And then this, we have this. And we say this is not a valley. So what do? We don't know. So this is a valley, right? So 2, 3. This, what do we do with this? This is like a valley, or you say this is not a valley, right? So this is not a valley, so I'll let it pass. Oh, because with this, we always want it to be small, right? We always want to be small. Okay, so maybe we can just say, okay, this one will set 1, up edge, down. It's like valley-ish, right? It's valley-ish. Okay, so we'll say this is 1, this is a 1, and this is a peak. Now we can set a 1. Now this is going down, so we don't set this one. Right? So this is a valley. So this is 2, 2, 2. This is going down to 1 and 2. Okay? Now we go backwards. We have this. Go up will be 2. Right? And then we say 2. This is 2. This is 1. This is 2. Now this shall be 3. So we take the larger, so it shall be 3. And then equal, don't care. Equal, don't care. Go up. Right? Go down. So I think a better way of dealing with this is Yeah. I will consider all these as valleys. I think I still consider this as a valley. These are not. So these we don't put value in initially. So we don't know this. Right? This is a peak. This is basically dropping down. So we don't know this. We don't know this. We don't know this. Right? This is 1. And we go up. This is a 2, but this, because this is 2. But these I don't know. This I don't know. Right? So I think that's the first pass. We have a valley. So we go up, up. That's a peak. Alright. And then next one is this down and this. So either this way or this way. These we leave it. Basically it's 0. We don't know. Right? We leave it as 0. And this is a valley, so we set as 1. Then go this is a peak, we set it to 2. This same, it's still 0. We don't know. This equal, we set to 0. Okay, equal set to 0. And right, and this is like a down, we don't know, so that's 0. So this is 0. This is a valley, that's a 2. This is equal, so set to 0. So basically this set to 0, set to 0, set to 0. These 3 situations are set to 0. And this set to 1, this set to 1. This will be plus 1, plus 1. Okay, yeah, so this is 1, this, basically this will plus 1. So that's the left to right. Now go right to left, I think is different. So this is still a 1, right? This is a plus 1. This is a plus 1, right? These are the basic, and also this, ignore, right? Ignore. So we say just ignore, and this is a valley. So if we look in this direction, this is a valley, right? So we have 2 valleys, and this one ignore. And this ignore. Wait, can we ignore that? I think this is a peak previously, so if we'll go left to right, yeah, it's gonna be ignore, right? Right to left, this is ignore. This is a valley, this is ignore, and this is ignore. So, okay, so this is ignore. This is a valley, so we set to 1. This, oh yeah, we have this. What's this? This is a plus 1. This is an up and edge, so this will be 2, right? So this is ignore. Okay, so this is ignore. basically just leave it be 0. And this is ignore, because it's this, it's ignore. This is the 1, this is going to be 2. Okay. This is going to be 3. This will be ignore. This is a valley. This will be a peak. The peak is always going to be the bigger of the two. This is... Hey, what is this? That should be ignore. Right? Just like on this side, this is ignore. Alright, this is s plus 1. 1, 1, this is plus 1. Yeah, I think this is ignore, so ignore this. This is a peak, no, a valley. So it will be this. So 1, 2, 3 is 6, 7, 8, 10, 11, 12, 18, 20, 21, 23, 24, 25, 26. So I got 26 out of this. That's making sense? Twenty-six. Okay, so maybe we can start working on this. So we have a left to right, right? Left to right rules. This is a 1. No, not this one. I'm redo this. So we have valleys. This. Okay. Peak. Now peak is valleys. Rising and peak. So this right, and this. Ooh, is this? Yeah, that's a peak, right? This is also a peak. And we have ignore. So ignore this, right? Then this, ignore because it's going down. Probably should be one more, yeah, this one. So these are all the possibilities for them. So the 3 things to arrange. All right, boom, boom. No, there's one. It's not all of them. This is already, now that's wrong. This is a no. This is right. It's right. It's this one. It's this one. This one. This one. Right? That's everything. So we have a peak, a valley, peak, uprising, downrising, static, all this. Go up, go down, up, down. Okay. So this ignore. This is that not a valley? No, we say we don't know because it could be like that, right? That's not a value. So that is a not sure, right? That is a not sure. So we always just focus on this, right? We focus on this, you're not sure. But it's interesting, like we have rising as this, right? Because that's rising. And this will be rising. Oh, this will be the valley. So if we go right to left, right? So we have valley, that's valley, and this, that's a valley, right? We have a rising and peak. This, this, and peak, peak, this, right? That's also a peak. And then we have ignore. Basically, the rising this way, right? And this, right? This. We're missing one. Which one? Handle this, handle this, handle this, handled. This one. Oh, we handled. This, yeah. Right, these are ignore. But these ignore have already considered here. Right, this one considered. This one considered. This is always ignore. This is this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and these are the rules. And another rule is at peak, we always pick the largest value. Okay, let's give this a shot. Oh, that's interesting. I need to have this open at all times. Okay, hold on, let me pull it up. So with these rules, we're just gonna go left to right and then right to left. Okay, but to make things easier, I want to add another one. Ooh, can we even add another one? I need to create a new ratings. Okay, that's fine. Let's say int, right? Modified ratings, rats. Ratings dot length plus 2, right? We say equal to this, right? Then we say mod rats 0. I want to put a giant value. We can say integer dot max value. Let's put it here as well. Mod rats dot length -1. That's gonna be integer dot max value as well. So the front and back all max value out. Then for int I equal to 1, I smaller than ratings dot length I plus plus. Ooh, that is not right. I should start from 0. Okay. Then we say mod rats I plus 1 equal to ratings I. So by doing that, we use a mod rats, right, to contain everything. Now what we need is it's not the score, the number of what? Candies. We need a candies. Okay, we need candies. Let's get candies. So we say int this candies equals new int ratings dot length. and we want to initialize everything to 0. So for int I equal to 0, I smaller than rating star length I plus plus, right? I want to set everybody to 0. That's okay. Oh no, we don't have to because it's already 0. Default is 0. Hold on. So default values are zeros. So no need to initialize. Default value is 0. We don't have to initialize again. So now we're gonna do, right? Now we're gonna do. So we're gonna say this is a left to right. Left to right. Let's see. Values, right? Values are 1, 0, 1 is value, 0, 0, 1 is value, right? Rising and peak. That's, let's say 0, 1, 2. That's a peak. 0, 1, 2. 0, 1, 0. And 0, 1, 1. That's peak. And ignore is gonna be what's ignore? That's 2, 1, 0. Right? That we ignore this. 1, 1, 0. Ignore this. 0, 0, 0. Ignore this. What's the last one? Ignore is 1, 0, 0. We ignore. Okay, so we're gonna ignore. So value set the middle to 1. Increment middle by 1. Okay, so let's handle this first, right? And then we're gonna do right to left. Because right to left is it could be slightly different, but you know what? Hold on. Let's split it out. I want to split it out. Peak is slightly different compared to compared to the rising. So rising is this, right? So we're gonna have a peak. So rising is just increment by 1. That's perfect, fine. And peak is also implement by 1 and also take the max. Right, and also take the max. We have to take the max for the peak. And these are ignore. Yeah, just ignore. I already said it's ignore. Okay. So what do? We're gonna start from 1. No, that's easier, right? Nah, what would be the easiest way to handle? No, it has to be 1. And then this is gonna be moderate star length. Dude, the length is actually plus 2, right? So I want to go, so it will be mod.rats minus 1 is the last one, right? So so it has to be minus 1, okay? So now what we're gonna see is to consider if it's a value, okay? So we say check value. Oh wait, hold a second. Oh, I have a candy, so check value. So how do we check value? If mod.rats I is smaller or equal to mod.rats I minus 1. So we handle this and this. And mod.rats I is smaller than, because it has to be smaller than mod.rats I plus 1. Okay, if these are true, then the value has a set. So candies I has a set to 1. Okay, else if. All right, so now we need to check. And don't put it here. Let's put here. Check value. So else if, now we're gonna check rising. Else if mod.rats I is larger than mod.rats I minus 1, and mod.rats I is smaller than mod.rats I plus 1. Right? If that's the case, this is check rising. Then candies I shall equal to candies I minus 1 plus 1. Okay, else if, now we're gonna check for peak. Peak is if mod rats I is smaller. No, wait, hold on. Larger than mod rats I minus 1. And mod rats I is larger or equal to mod rats I plus 1. Right? So this is larger than the left. This is larger or equal to the right. So this is peak. Right? Check peak. Now peak is interesting. We shall say candies I shall equal to the maximum maximum candies I and candies again I minus 1 plus 1. So that's the difference. All right, the remaining is ignored, so we basically don't even go through them. So we just go through this, done, right? Left to right. Now we're gonna go right to left. Same stuff. Okay, so we go valleys first. 101 is still the valley, and this is gonna be 100. Right, that's the valley. So we set the middle to 1. Rising. Rising is only 210 is only the rising. So we say increment middle by 1. Okay. Next is peak. 010, of course, is still the peak. And we also have 110. 110 is also the peak. Right, so it's like opposite to this. So this is the same. We can just copy and paste this. Right, copy and paste this. Last one is ignore. So we're gonna ignore 0, 1, 2. Right, we're gonna ignore 0, 1, 1. Ignore 0, 0, 0, and ignore 0, 0, 1. Right, we're gonna know all these. So these are ignored. All right, so for int I equal to, where do we start? Mod rats dot length minus 1 minus 2. I is larger or equal to 1, because that's the last one we want to hit. I minus minus. Okay, so again, so it'll be very similar stuff. So let's just copy and paste the whole thing, and we are going to make changes. Okay, so the first one, we're going to check value. Why? Something's wrong? Duplicate. Yeah, I know it's duplicate. So we're going to check for values. So values, if this is smaller than, and that's not true, smaller, and this is smaller or equal to on the right hand side. Okay, so check for rising. If it's rising, so this shall be smaller and this shall be larger. Right, this is smaller to the left, this is larger than the right. It's rising. And the last one, we need to check for peak. This is larger or equal to the left. Right, the peak is going to be larger or equal to the peak, and this is going to be smaller to the right. Then we will do, actually this is not right, this is should be plus 1, because we go right to left, and this is a plus 1, right to left. Okay, so now we are done with this. Then we can say int res equal to 0. Okay, then for int I equal to 1, I smaller than mod rats dot length minus 1, I plus plus. So what we're gonna do is say res plus equal to candies. Oh, why don't you do candies? Oh yeah, why don't you do candies? So int c, I think I can even do this. Int c of candies. All right, so that's plus equal to is c equal to 0. Right, if c equal to 0 is 1, if c is not equal to 0, then we do c. And we're gonna return res. Oof. We have a lot of test cases for this, so which is good. What is this? Manual array copy. Oh, I can do array copy. Wait, hold a second. How do we do array copy? System.array copy. Ratings when a copy to mod rats. Source position. Wait. Source position. Destiny. That's a very weird way of doing this, huh? So ratings is the source position. And mod rats is destination. And destination position. Oh, the starting position. I see. So the rating is the source. Where is the source position? And this is the destination. That's the starting, yes. And then the length. Ooh, this is beautiful. This is a great IDE, huh? That's a great IDE. All right, let's not praise the IDE at the moment. Let's check. Is this correct? The hell? Oh, out of bounds. What the? Oh. That's all right. That's all right. Wait, how? How is this out of bound? Well, don't guess. No need to guess. Let's just debug this. Let's debug this thing. Let us debug this thing. It's okay. It's okay. So int ratings. Okay, int ratings equal to new int 1, 2, 3. I'm pretty sure it's 1, 2, 3 giving me trouble, right? Is 1, 2, 3 giving me trouble? Yep, it's 1, 2, 3 giving me trouble. All right, that's fine. Let's see. We're gonna say candy ratings. All right, let's put. I don't know. Let's just put the stop point here. Okay, let's debug this. Wait, hold on. You didn't. There we go. Okay. All right, ratings is good. Modified, that's good. And we start from I equals 1. Modified length is 1, 2, 3, 4, 5. 5 minus 1 is 4. And I smaller than 4, so 3. So 0, 1, 2, 3. That is correct. All right. And then we're going to check to see this. It is a valley, right? It is a valley. So we set it to 1. Oh, I see what was wrong. Yep, I see what was wrong. Okay, so we can stop this. I know what was wrong. This has to be the candies. The things that's wrong with the candies. It has to be -1 because I start from 1, right? This has to be, oh, dude, -1. This has to be -2. This has to be -1. This has to be -1. This has to be -2. Oh my god, we have to change this one as well. Actually, it's the same. It's the same. It just all has to be -1. Oh, this is just gonna be I. This is gonna be -1. This is gonna be I. Yeah, let's run it. Doing all right. That's okay. That's okay. Let's. It's doing all right. It's okay. Debug. Let's see. Right, that's 1, so we can actually see candies. Candy is 1. All right, that's right. Next shall be, this shall be false. Okay, so we go here. This check rising, this shall be rising. Right, I is 2, so 1 shall equal, so this should be good. And the last one, right, this is the last one. I equal to 3, right, 0, 1, 2, 3, so it's this. And this is still rising. And I is 3, so 3 minus 1 is 2, so that should be good. Done. Okay. Oh, so problem is here. Problem is here. I starting from, hold on, I minus 1, less minus 2. Okay, I start from 3. 0, 1, 2, 3. Okay, so it's not a valley. It's not a rising. Candy's eye. Oh, I didn't see that. Huh. Well, it's not a rising, right? It's not rising. And it's not a peak. Oh? How are you a peak? I is larger equal to, yes, I need to smaller than this. Wait a second. That's not right. I is this, right? I 0, I is 3. Yeah, I is 3, so 0, 1, 2, 3, it's a 3. Is 3 larger or equal to this? Yes. And this has to be smaller. Oh, dude, it's not smaller. It's not smaller. It's bigger. I think I got this one wrong. Hold a second. Hold a second. Let's pull this up again. Yeah, I think I got the condition wrong. Check peak, right? Peak is, this is larger. Yeah, you see the peak is larger. I don't know why this should be larger, right? Okay, and then get me confused. Did I get a rising right? Not just small, large. I think this shall be right. 6. Yeah, I think this is 6. Hold on, let me copy and paste this thing. Okay. Back here, and all right, run again. Oof, didn't work. Ooh. So 6, 4, 7, 6, 4, 7, 15, 15. Oh, the last 3 got issue. Should be 18, I got 16. Okay, that's fine. So the third from the end. This. Huh. How are we not getting this one right? Okay, which one is that? I don't even remember which one is that. Drew it again. So we have 1, 2, 3, 4, 3, 3, 3, 2, 1. This one. All right, go ahead. So we said this is 1. Oh. 2, 3. Okay, so far so good. I probably need to get another one. Yes. So 1, 2, 3, 4. Okay. Then it's this shape. This shape shall be ignored, which is 1, 0, 0. Right? That should be ignored. So next one shall be ignored. Yep, that's good. So we ignore it. Next, I is 5. 1, 2, 3, 4, 5. So this shall be ignored as well. Yes. So next one shall be ignored as well because it's 1, 1, 0. So next one shall be ignored. Okay. So next one is a drop. Shall be ignored. Next one is the end. This one shall be picked up. I is 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, my bad. This one's still ignored. Oh, wait. 0, 1, 2, 3, 4, 5, 6, 7, 8. Wait. We have a valley there? That is bonkers. Wait, hold a second. How many do we have? I is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, hold a second. Something is not right. Yep, something is not right. Wait. Maybe it is right. I mean, this is how I expect, right? This is how I expect. This is 1. But it's just a little bit weird that at the end, I equals 9. 1, 2, 3, 4, 5, 6, 7, 8, right? That's 8. That's 9. 1, 2, 3, 4, 5, 6, 7. I must have missed, but so far so good. Okay, so far so good. Candies is good. Okay, let's keep going. All right, so I is 9, right? So we start from here. That should be a valley. So that's good. Next is here. We shall increment. Yes. Good. Next is this, which is a peak. Because it's a 1, 1, 0. Check peak. Do peak. Good. Next is ignore. Good. Next is, I think that's an ignore as well. That's a 1. That's not ignore. That is a valley. That is a valley. 1, 0, 0 is a valley. So that's a valley. So we set to 1. Perfect. And then that is a peak. Oh, here is the problem. Here is the problem. -1. Okay, I think we got this problem. So we run this. 18. Is that 18? Yes, it's 18. Okay. Wow. The power of the debugger. It sounds like booger. Debugger. Okay, try it again. Isn't this look promising? All right, give it a shot. I was a bloodbath last time. All right. Look at all the analysis. Man, it's an hour and 25 minutes. Jesus. So, counts as an improvement. Yeah, it surely is an improvement. I don't think I did it myself. I will be very impressed if last time I did it by myself. I don't know. I'm gonna have to check. Did I write anything? 2 pass, left to right, and then right to left. Yeah, but much simpler than how I was spinning it. Wait, did I solve this myself last time? Oh my, I did solve this myself. Ha! Solved it myself the last time. And how about this one? Oh, heap. I use a heap idea. So what did I say at the end? I was thinking about heap, but I thought heap is not gonna work. Oh, I see what I was doing. Left to right. I know. Is this the better official solution? There's an official solution. It used to be, now no longer. Okay, we gotta read through this. What should I say? Well, we solved it, but it's not the best. It's not the best. All right, let's just wrapped it up. Man, I still have work to do today. The struggle is not over yet. 135. 2 passes, left to right. Left to right, identify the valleys, rising, peak, and ignore. Do the same for right to left. But when the only not to left, when hit a valley, right? When hit a valley, set it to 0. Set the candies to 1. When hit rising, increment the candy count. When hit peak, retain the max count. When hit ignore, just ignore. At the end, tally all the candies. If there is a cell, there is a position where no candy has been allocated, set it to 1. But yeah, it's not really the best, because I think I did basically that 1 pass, 2 pass. If you count it, that's 3 pass, right? That's like 3 passes in total. 4 pass in total. Well, I'm gonna do the same thing. I will not continue today. I will deal with this baby tomorrow. I'm just lazy. Not lazy, just there's only so much capacity I have. Alright, let's just put this one in and call it a day. Wow, we need to do this, we need to do this. Jeez. You need to throw me an easy one tomorrow so I can go through all of these problems. And this one, I'm not happy with this one at all. It's the yesterday's. I'm not happy with this one at all. It looks ugly. And also this, we still have to handle this. Oh my god. Alright, anyway, that will be it. I'll see you guys tomorrow. Adios.